Hi everyone, we are the Hyper Bosses.
I'm Carl.
I'm Johan.
I'm Neil.
And I'm Seth. We are here to discuss about the characteristics and parts of the conic section hyperbola.
We hope you learned something from this video.
So, let's get started.
Hi everyone, and welcome to our tutorial on hyperbolas. So the definition of a hyperbola is a set of all points in the plane such that the absolute difference of the distance from any point on the branches to the foci is a constant. So all hyperbolas share common features. The center of the hyperbola has the coordinates h and k.
So, the vertices of a hyperbola are found to the left and to the right of the center. This is the case if the hyperbola is a horizontal one, and the vertices are also the endpoints of the transverse axis. So, the foci of a hyperbola indicates where the branches open and is collinear with the vertices. So our foci of this hyperbola is located to the left and to the right, which is c distance from the center.
Asymptote is a line such that the distance between the curve and the line approaches zero as they tend to infinity. Latus rectum is a line through the focus whose endpoints are on the branches.
So the principal axis is a line that passes through the center, the vertices, and the foci. The transverse axis is a line segment found on the principal axis. Its endpoints are the vertices, and it is also defined as 2a. So the conjugate axis is a line segment that is perpendicular to the principal axis. Its endpoints are the co-vertices. It's also defined as 2b.
Using our standard equation, we can derive the values of a, b, and c. To get the value of a, we get the square root of the denominator of the positive term, which is square root of 6. To get b, we get the square root of the denominator of the negative term, which is 2. To get c, we use the Pythagorean theorem, c squared is equal to a squared plus b squared. Hence, we got c is equal to square root of 10. Using the standard equation in the values of a, b, and c, we can get the center, foci, and vertices. To get the center, we have to get the values of h and k. The value of h is -5, and the value of k is 2. So there goes the coordinates of our center. To get the values of our vertices, we have to add and subtract the value of a from the x-coordinate of our center, which is plus minus square root of 6. So the value of our first vertex is -5 plus square root of 6, 2. And the value of our second vertex is -5 minus square root of 6, 2. So there goes the values of our vertices. To get the values of our foci, we repeat what we did with vertices, but this time with the value of c, which can be written as plus minus square root of 10. So the value of our first focus is -5 plus square root of 10, 2. And the value of our second focus is -5 minus square root of 10, 2. So there goes the values of our foci.
Y minus k is equal to positive negative b over a times x minus h is the formula that we are gonna use. We are gonna substitute the given to make use of the formula. In the end, we're gonna have y is equals to square root of 6 over 3 times x plus 5 plus 2. And y is equals to negative square root of 6 over 3 times x plus 5 plus 2. The formula that we're gonna use to get the conjugate axis is 2 times b. So we're gonna have 2 times 2 which is equals to 4. Now 4 is our conjugate axis. The formula that we are gonna use for the transverse axis is 2 times a. We're gonna substitute the given, so we have 2 times square root of 6. So we're gonna have 2 square root of 6. Now that is our transverse axis.
The eccentricity of a conic section is a measure of how much the conic section deviates from being circular. We find it by using the equation E equals C over A. Since we have the values of such, we simply substitute it, and that becomes square root of 10 over square root of 6. We rationalize it by multiplying it with square root of 6 over square root of 6. And that gives us E equals 2 times the square root of 15 over 6. We simplify it, and that becomes square root of 15 over 3. And that is the eccentricity of our hyperbola. We find the length of the latera recta by substituting the values of a and b to the equation for the length of the latera recta, which is length of latera recta equals 2b squared over a. That gives us 2 times 2 squared over square root of 6. 2 times 4 over square root of 6. And that gives us 8 over square root of 6. We rationalize it by multiplying it by square root of 6 over square root of 6, giving us 8 square root of 6 over 6. We simplify it, and then we get 4 square root of 6 over 3, which is the length of our latera recta. The endpoints of the latera recta are found on the branches of the hyperbola. Since we already have the length of the latera recta, and a pair of endpoints are collinear with the focus, we divide the length of the latera recta by 2, and that gives us 2 square root of 6 over 3. We add and subtract such value to the y-coordinates of both the foci of the hyperbola because we know that the endpoints of the latera recta of a horizontal hyperbola are found above and below each foci. So that gives us negative 5 plus square root of 10, 2 plus 2 square root of 6 over 3, negative 5 minus square root of 10, 2 plus 2 square root of 6 over 3, negative 5 plus square root of 10, 2 minus 2 square root of 6 over 3, negative 5 minus square root of 10, 2 minus 2 square root of 6 over 3.
So, to look for the general equation of our hyperbola, we start off with the standard equation and multiply it to the LCD of both of the denominators, which is 12. Then, by simplifying it and distributing 12, we get 2 times x plus 5 squared minus 3 times quantity y minus 2 squared is equal to 12. Then, by expanding the square of the binomials, we get 2x squared plus 20x plus 50 minus 3y squared plus 12y minus 12 is equal to 12. Then we transfer all of the constants to the left side and arrange them by degree, which gives us 2x squared minus 3y squared plus 20x plus 12y plus 50 minus 12 minus 12 is equal to 0.
Then by simplifying and combining like terms, you get 2x squared minus 3y squared plus 20x plus 12y plus 26 is equal to 0.
So we are given a hyperbola with center at -2, 4, transverse axis of length 8, conjugate axis of length 6, and it opens left and right. We all know that the transverse axis is equal to 2a. 2a is equal to 8. Divide both sides by 2, we get a as 4. The conjugate axis, on the other hand, is equal to 2b. 2b is equal to 6. Divide both sides by 2, we get b as 3. Now, we use the standard formula of hyperbola that opens to the left and right, which is quantity x minus h squared over a squared minus quantity y minus k squared over b squared is equal to 1. Now it's time to substitute the values. So we get x plus 2 squared over 16 minus y minus 4 squared over 9 is equal to 1.